In this video, I'm going to find the derivative and values of x where the tangent line is horizontal for f of x equals x to the fourth times x minus 9 to the fifth. This derivative is going to require a product rule. We've got the function x to the fourth and we've got the function x minus 9 to the fifth, as well as the general power rule. We don't have just x to the fifth, but we have x minus 9 to the fifth, so we have to figure out how to take that derivative. Finally, the tangent line is horizontal. What does that mean? That means the derivative of the function is 0. So we're going to take the derivative and then we're going to set it to 0 and find the values of x for which it's 0. Okay, so let's take this derivative, f prime of x. We take the product rule, derivative of the first function, which is 4x cubed, times the second function, x minus 9 to the fifth, plus the first function, x to the fourth, times derivative of the second function, general power rule, 5 times x minus 9 to the fourth, times derivative of the inside function, which is just 1. One more parenthesis. Okay, so let's simplify this a little bit, and then we'll set it equal to 0. So in both of these terms, I have an x cubed, right? This one's got an x to the fourth, but both terms have x cubed. So we'll factor out an x cubed. Both terms have an x minus 9 to the fourth, x minus 9 to the fourth. And what are we left with? We are left with a 4 times x minus 9 plus 5x. So that's x cubed times x minus 9 to the fourth times 4x minus 36 plus 5x, so that's 9x minus 36. So that's our derivative. And now we want to set it to 0. So 0 equals x cubed times x minus 9 to the fourth times 9x minus 36. And so this is 0 when one of these terms is 0. So this is going to be 0 when x equals 0, or x equals 9, or x equals 4. So if I think about this function, the tangent line to this function is horizontal when x equals 0, x equals 9, and x equals 4. The derivative is equal to x cubed times x minus 9 to the fourth times 9x minus 36. But if the question were simply what's the derivative, then I certainly would have stopped at this first line because it's correct, that's the derivative. I knew I was going to do something with that derivative, so I did the math to simplify it.